Function Standard 1. We are still looking at representing functions. Today we're going to look at our last learning target, which is number 3, and that states I can show the relationship between the inputs and the outputs of a function by graphing them as ordered pairs on the coordinate grid. The storyline that we're going to be looking at states the Football Booster Club orders 7,500 liters of water for the Friday night's game. The sale of the water averages 150 liters per minute. The equation that represents this context would be W equals negative 150 M plus 7,500, where W represents the amount of water in liters and M represents the number of minutes in the game. So we're going to take a moment here and really look at that equation because we'll be using that equation over and over. So W again represents how much water they have left. Now, reminder, they started with 7,500. So W represents how much water is still available for people to buy. The negative 150. Well, 150 came from here. Remember, the sales of water averages 150 liters per minute. So every minute that goes by, 150 liters of water is purchased, which means you have less that much. So that's why it's a negative 150. M represents how many minutes there are in the game. And then again, you're going to add that to the amount of water we had at the beginning, which again was 7,500 liters. So we look at our table here. We notice that if there's 0 time or 0 minutes, then we have that 7,500 liters, which makes sense because that's how much water we had at the beginning. 10 minutes go by, we check the math here. So if 10 minutes go by, we're going to input. So these are your inputs. These are your outputs. In this case, our inputs are minutes. Our outputs are liters. So when we input 10 in for our minutes, and we add that to the 7,500, then we should mathematically get the 6,000, because that's how much water is represented or what's left. So negative 150 times 10 would be negative 1,500. You add that to 7,500, and you get, do the math there, and you get 6,000 liters. So there's 6,000 liters left of water after 10 minutes of the game. Erase this to give us some room here. The next line or next row here tells me that there are 5,250 liters of water left. The question is, they want to know how many minutes would have passed. So this time we actually have to do the math or the algebra to figure it out. So I know how much water, 5,250. It's going to go down at that 150 liters per minute. We don't know how many minutes have passed, but again, we know that we started with 7,500. Now, it's been a while since we've inversed or solved for algebraically. So reminder, we want the M alone. So we want to figure out how many minutes that takes. So since this is adding 7,500, we're going to subtract 7,500 from both sides. Put that in your calculator. And I get negative 2,250. That's going to still equal the negative 150 minutes. Now, if I want to get rid of the negative 150, that's being multiplied times the minutes. So I'm going to divide by 150. So divide both sides by negative 150. Sorry, my calculator's acting goofy here. And we get 15. So 15 minutes have passed since the game started, and we now have 5,250 liters of water left. I'll erase it again so we can use our next step. So our next step states here, We want to know how much water is left after 30 minutes of the game. So since the input is about minutes, we're going to input 30 here. So we have negative 150 times the 30, and we're going to add that to 7,500. So we're going to take negative 150 times 30, which is negative 4,500, and we're going to add that to 7,500, and we get 3,000 liters left. So after 30 minutes, we have 3,000 liters of water left. So we go to our next row. Again, we see that we know the input, so we know the minutes. We want to know 35. So let's erase here. So again, we know the input. The input is 30 minutes. 35 minutes. We want to know the output. So we're going, in other words, we want to know how much water is left. So we're going to take negative 150 times, this time 35 minutes, and we're going to add that to how many liters we had at the beginning. So 150 times 35 gives us a negative 5,250. And we're going to add that to the amount of liters at the beginning. Which leaves us with 2,250 liters of water left. That is making sense as we look at this table. As our minutes are going up, in other words, as the time goes by in the game, then our output of how much water we have left, since we're selling 150 per minute, should be going down, which it continues to do. This one here, looking carefully at it, we know the output, so we know how much water is left. We know there's 1,500 liters left. So this time, notice we're looking for the input, how many minutes have gone by. So this is where we have to do our inverse operation, solve it algebraically. So we're going to subtract first, which leaves us with negative 6,000 equals negative 150 m. And remember, the inverse of this is multiplication here because it's negative 150 times the number of minutes. We're going to divide. So 6,000 divided by 150 leaves us with 40 minutes, which looks like it's a great plan. It keeps continuously going down here with our water, but our minutes are going up because more of the time at the football game continues to go by. This time we know our input on our next row. We're looking for our output. Notice that we know our input, looking for our output. So this time we're looking for the water, how much water is left. So that's where we're going to take the negative 150 times the number of minutes, 45, add that to 7,500. So negative 150 times 45, and then you're going to add that to how much water was at the beginning, and we only have 750 liters of water left after 45 minutes. So the last row asks the question, when are we going to have, we want to know the output of 0. So when we have 0 water left, which hopefully is towards the end of the game, or the concession stand's not going to have any water and some people are going to have to choose something else to drink, we're going to put 0 water. So when, in other words, do we run out? How many minutes into the game? Okay, so again, same inverse operation. We're going to subtract 7,500 from both sides. 0 minus 7,500 is negative 7,500 equals negative 150 m. Again, this is multiplication to inverse, or to do the opposite. We're going to divide. So negative 7,500 divided by negative 150 is 50 minutes. So within 50 minutes of the game started, we have run out of water if we continue at that constant rate of selling 150 liters per minute. Now, to graph this, when we look at inputs, these are our X values, and when we look at outputs, these are our Y values. So when you make these ordered pairs up here, we're technically going to take each of these rows and make an ordered pair. So when there were 0 minutes, we still had that 7,500 liters of water left. After 10 minutes, we had 6,000 liters left. Okay, and notice that I'm just taking the input, which is your X, and putting it here, and your Y value, which is your output, becomes the Y coordinate of the point that we're going to graph here in a little bit. We have 15 minutes. We found out there would be 5,250 liters left. After 30 minutes, there's 3,000 liters left of water. After 35, there's 2,250 liters of water. I'm gonna bounce up here. 40, that's your input. Your output would have left you with 1,500 liters of water. After 45 minutes of input, your output would have been 750. Your input here is 50, and we've run out of water at 0. So if we do this right, it should graph in a linear function. And a reminder from the last learning target, linear means when graphed a straight line, or the constant rate of change, which I can hear in the context, is 150 for every minute. So let's graph this. So here's 0, 7,500. Remember, X is this way, so you do that one first, and then Y is your vertical axis. So 10 on your X, 600 on your Y. X is 15 minutes. 5,025. Then we're going to go to 30, which was up to 3,000. Whoops. Erase that. I went too far. So 30 again, and then 3,000. There's my X, and that's my Y. 35. There's 2,000. 25, 40 minutes, 500 liters left. 45 would be 750, and then the 50 minutes, there would be 0 liters left. So a couple things when you graph, first of all, look at your axes, make sure you understand what they're going by. So if this is 0, that has to be 5, 10, and then 15, and so forth. Over here, it's a little trickier. This is 0. This is a blank, but that's 1,500. So if you think about this has to be evenly spaced out, well, halfway between 0 and 1,500, of course, is 750. So that kind of helps you. And then you'd add another 7,050, so that's 2,250. So if it's easier for you to write those, the other thing I'd recommend is maybe labeling it so you really remember what you're talking about. So remember, this is minutes of the game left, and this is how many liters of water. So that always helps when you are graphing. Last thing to notice, since we talked about this being a constant rate of change, a linear function, then when you graph this, when you get done and you take a straight edge and you go through all those points, it better make a straight line because it's going down at a constant rate of 150 liters per minute. So if it doesn't make a straight line, then you know, since it's a constant rate of change, then you know you did something wrong on the table and you need to go back to that table and look. I hope this helped. Have a great day.